right? So you can go
Mm-hmm.
through this the previous two
Okay.
slides, and we will discuss in detail. If you have any
Oh,
doubts, you can come back to that
yeah, yeah,
anytime.
sure.
So here
Okay.
we are discussing about the online analytical processing in BI. So the BI of business analyst, the capability to analyze business processes. So what do we analyze? They want business analysts want to analyze the KPIs and
Mm.
in fact table, what are the facts and what are the KPIs we have. KPIs means key performance indicators. So every business wants to analyze the key performance indicators in their businesses. So for the purpose, we multi-dimensional modeling. So what
Mm.
are the questions multi-dimensional modeling answers? For example, there are different dimensions like sales, material, time, and key figures like sales amount and sales quantity. So in all these dimensions, they are they will help to describe the key figures. So in multidimensional modeling, you have questions like what is the sales amount by sales department, by material group, by month,
Mm-hmm.
or show me the sales amount for a sales department 1000 by material ID for a month. So all these questions, these such questions are the questions which managers ask you regularly. So all the questions you must be able to answer. The data must be able to answer. Here we have a big data concept. So there are millions of billions of records coming on every year. So here we have to all the data is used to answer. So for that purpose, we have to build the business warehousing and report on that so that and we need a different analysis. So we need a multi-dimensional analysis that which
Mm-hmm.
we cannot do in OLTP system. Online transaction system, we can do a flat. There will be a flat structures, but we cannot do multi-dimensional analysis in OLTP systems.
Mm-hmm.
For that purpose, BW is used. So why do we use BW? Why not different data warehousing? So there are questions like that. Why BW only? Why not anything else? So there is a BODS. Of course, BODS is there, but BW is like it is tightly integrated with ECC. That's the
Mm-hmm.
first thing. And data extraction from ECC is much easier with SAP NetWeaver BW.
Mm-hmm.
So BW has pre-configured business content. That's the main point. So business content objects which are available in BW are same as they are same as ECC. You just have to install just like a plugin. You
Mm-hmm.
have data sources in ECC. You have metadata in BW, and once you install it, you are installing it like a plugin, and you are ready to load data. So
Mm-hmm.
for that purpose, BW is has lot priority, and BW is already a part of the landscape. For the purpose, you have a homogeneous landscape from ECC to B. So by connecting RFC, you can connect ECC to BW. And another thing is the BW is the foundation for most SAP products. Like there are different products at this moment, Lumira and Fiori. So all these products, BW is the foundation.
Mm-hmm.
So these are the advantages of BW. So that is why we have to learn BW. BW has a lot of advantages compared to other data warehousing tools.
Mm-hmm.
So
So, what is
there are
ECC? Hello, Shahid?
yeah, ECC is
Mm-hmm.
R3 is called ECC.
R3 is called
So
ECC.
ECC,
Okay.
yeah, now it is called ECC 6.0. Before it
Uh-huh.
was R3,
Mm-hmm.
and just like as you know, in 1972,
Mm-hmm.
SAP even started with the R1.
Yeah.
So R1, R2, R3, and now ECC 6.0. So now
Mm-hmm.
it is a part of NetWeaver 2004 as.
Mm-hmm.
So now it is a photo based. So it is part. I mean, it is part of portal NetWeaver 2004. So here now, as we are entering into the 21st century, since
Mm-hmm.
2000, there are a lot of implementations, there are changes, and all the sector is
Mm-hmm.
changing very fast. The data requirements are changing. The data which gives us value. I mean, we are into the data warehousing, business warehousing, we are into the lab system. So, historical data, the data which gives us the value, it is growing rapidly year by year. And for that purpose, we don't have we have to overcome we have to overcome with that data, and there is a lot of data which is untouched, which is not reported, and we have to add that data as well. So for that purpose, we need fast, efficient tools. So in the future, we not cope up with that requirement of data. Today, we have HANA database, and just
Mm-hmm.
like that, which can be, I mean, it is a in-memory computing. So you can see terabytes of data. You won't see before in a company. You won't see any terabyte worth of data. I
Mm-hmm.
mean, you will see in GBs, you will see in MBs and GBs, but not in TBs. Now it is possible that you have terabytes, and in the future you will have zettabytes.
Mm-hmm.
So it is like growing rapidly. Our market is growing rapidly, and that is why there is such a huge need for the, I mean, multidimensional analysis and perspective of the data. So here there are theories on data modeling. We have different theories on data modeling, and generally we have conceptual data model, logical data model, physical data model. In conceptual data model, it defines the problem rather than giving the solution. It means it defines the problem exactly. You can have a graphical representation of the problem, and with the help of entities and their relationships. It is ER modeling. So logical data model defines a logical solution to a data project. Means it provides more details than the conceptual model. So that's the difference between logical and conceptual. Physical data model describes the implementation of data in a physical database. So we are going to discuss conceptual schema. So in conceptual schema, you will have ER modeling, and we are going to see our data models. For example, it is not practically done though in any companies now, but you can, for the understanding perspective, I'm going to show you as we are discussing the prerequisites how to see the ER model and how to analyze our requirement. So ER model is a detailed logical representation of the data for an organization or business area. It is expressed in terms of entities and their relationships. So it is a good way of seeing the relevant business objects and their relationships. So for example, you will have a business analyst in a company who knows.
Mm-hmm.
I mean, first of all, let's talk about the roles in BW. We have generally we'll have a project manager. We will have a business analyst, like business subject matter consultant. So BW, and we will have a data architect, and we will have an application developer, and business developer, and you will have a adapt developer for the. I mean, you generally in organizations, this is like you will have all this in a. I mean, theory wise, but generally you will see like ABAPers, there are people hiring like a BW ABAP consultant, and one BW consultant, one techno-functional consultant, and one or two BW consultants. Like the different there are different criteria of according to company. I mean, they
Mm-hmm.
hire multi skills sometimes. A few of them are multi skills, few of them are BI. Like that, it will happen because as per the experience, people get multi skill.
Mhm.
You understand that? I mean, after 3 4 years experience,
Mhm.
or after 5 6 years of experience,
Mhm.
BW consultant would have some of the functional knowledge or
Mhm.
some of the programming. So it
Okay.
will be, I mean, few of them will be like strict at the time.
Okay. So like actually
So
we are concentrating on business intelligence, right? Both business intelligence and business warehousing.
business warehousing is a previous version. I
Okay.
am going to discuss the differences. I have a document to give you for today. We
Okay.
have a document which will answer this question exactly, but I'm telling you,
Mm-hmm.
I mean, we will discuss it later, but business intelligence
Yeah.
is 7.0 version
Mm-hmm.
and the business warehouse is the 3.5 version. That's the only
Okay.
difference, and we are going to see business warehouse first for master data, and then we will move ahead to the business intelligence.
Mm-hmm.
So you will have, I mean, all the answers here for the
Mm-hmm.
different. We have some differences. I mean, I have some data flows drawn, some data flows as well.
Mm-hmm.
Is some kind of my architecture. I hope it looks good, and
Yeah.
it is. I mean, this is the data flow for 7.0, and this is the data flow for 3.5.
Mm-hmm.
So let's see it later.
Okay.
So generally, for example of requirement gathering, a business analyst describes his information needs and business process, like track the performance of materials with respect to customers and sales persons. When you see this sentence, right?
Yeah.
When you are having, I mean, a conversation with the user, you will that's how you will, I mean, when you discuss it you have to take your I mean information from the verbal transcript. So here when the business analyst says that track the performance of materials with respect to customers and salesperson, you have to see the your nouns. I mean, you have to see your with your perspective that you have a material and you have a customer and salesperson. So these are
Mm-hmm.
the norms we have. So the norms are basic business objects and are usually called strong entities. Speaking from ER modeling perspective, so this is a like I mean ER modeling helps you understand the concept of BW very well. So you have three norms: customer, material, salesperson. Then you have to further ask the business analyst about the relationship between them, like normally the relationships like you have a one to many or many to many relationships like that, so you have to draw them. I mean, once you for a clear picture. So then you have to further ask for I mean business analyst how to measure the performance. So this will this will give the basic facts. Facts are like you have a key KPIs in facts, and then there is like for the intersection entity you can see here there is a sales order. You have three dimensions first of all, uh, and then you came up with the requirement. So that is the you have one sales order. All those dimensions will be there will be one to many relationship between that. So that is what you have to create. You have, so you know that from customer information, material information, salesperson information in sales order, which will be helpful to create a sales order. You have to create a, I mean, you have to analyze the data.
Mm-hmm.
Here you have you have to further ask the business analyst for the dimension, I mean attributes of each and every dimension. For example, you have a material group. For in material group, you will have attributes like material number and material group name. So material group number and name, just like that, you have a material. So you should have a describing attributes. I mean, there is a characteristic material. it should have a describing attributes, right? For example, I'm talking about the some person. I'm talking about Ravi. Then you will have you will have your contact information, phone number, your email
Yeah.
ID, and etc. etc. A lot of attributes will be there. So just
Yeah.
like that, for every characteristic, there are attributes, and you have to
Mm-hmm.
draw those attributes. So all those attributes, for example, material, you have color, price, material type, name, ID, etc. And you have customer ID, customer name. So here you can see this is all master data. In our perspective, you have like one, two, three, four, five master data. So generally what we do is to load master data first and then we load the transaction data. So first of all, you set up the system with the master data like this. So now you got the clear picture, you got the requirement here. So here we got the requirement. Then you have to, I mean, you have to ask the business analyst further to, I mean, for the some relationships which are hidden relationships, or you have to draw your attention to the hidden or abnormal situations like that. So here, for example, you have any textile company or anything. You have material. In a textile company, you have a material, right? For example, you take Alok Industries. You have a cloth. They do textiles. So each cloth, each color has different cloths. I mean, different materials, polyester, cotton, etc., etc. And each material has different colors. Same as that,
Yeah.
like green, blue, white, red, etc., etc. So
Yeah.
there is a many to many relationship between these two. So you have to carefully see these relationships, hidden patterns.
Mm-hmm.
So generally the transactional structures, this is how the data will be loaded in the OLTP systems. So data is there in OLTP systems with respect to the RDBMs.
Mm-hmm.
So here you have dimensions and you have data, master data like this. So this one is, I mean, it is not good for the multidimensional analysis. For
Mm-hmm.
example, you have a query on revenue from a company over the last 2 years. It would require reading all transactions from the 2 years. For example, if you have to read all the transactions from 2 years, you can directly do it in OLTP system. It may go down, system may go down. That is a big disaster. Like
Mm-hmm.
for that purpose, we don't use the OLTP system for the historical perspective.
Okay.
So generally in our system, the OLAP specific data models are like we have flat structures, and then we have in I mean we have two types of models. One is key figure model and account model.
Mm-hmm.
So in even in any schema like star schema or snowflake schema, these are the two types of key models, key figure model and account model we use. So either the data is in key figure model pattern or either it is in account model pattern.
Mm-hmm.
So what is key figure model? Here you have in a flat analysis table you have this is this is a normalized way, and these are flat structures, and you will see the granular data. And for example, if you have in BW we have DSOs which provide granular data, and info cubes which provide summarized data. So it is based on different schemas are there like star schema and snowflake schema. When we discuss it, we will discuss about the differences. So here you have a key figure model. In key figure model, as you can see here, we have material month sales price discount. Here, key figure has the domination. Like every key figure has its own column. You can
Mm-hmm.
see that price is there, discount is there, sales is there. So here you have characteristics, month and material. So every key figure has its own column, and either it has some key figures or it doesn't provide values. It doesn't matter, but the column will be displayed. So that is the key figure model. And there is another model called account model. Here, what will happen is you will have one semantic which will display the name of the key figure, and you will have a column for the key figures.
Mm-hmm.
So there is the difference between key figure model and account model. In key figure model, you have key figures have different columns for every key figure. For sales, we have different columns. For price, we have different columns. For discount, we have different columns. So
Mm-hmm.
here in account model, we have one semantic column which will describe the key figure names, and we have a key figure which describes the value of the relevant key figure. So in this one, for example, you have generally in the real time, for example, if you have 100 key figures,
Mm-hmm.
say 80 of them are not used. In that case, what they do, account model will be saving space, right? So, for having every column, each and every column, even though we are not using the key figure, is unnecessary. So, account model can be used. But
Mm-hmm.
generally, we use key figure model.
Okay.
So what is star schema? Star schema is, basically it graphically represents like star. So that is why it is called star schema. So basically you can see that it has a fact table in the middle and the dimension tables surrounded to the fact table. So for that purpose, we call it a star schema because it is graphically representing a star. So we'll see what it is. So the relational link between fact table and the dimension tables is made with the surrogate keys. So here you can see in the fact table, you have every dimension there. We just saw this in ER modeling, right? The same thing. That is why I created this document on the same dimensions and same data. Like we have seen this in ER modeling just before.
Uh, no. ER modeling?
I mean, ER entity relationship model here. This one,
Uh,
you can see my screen, right?
yeah, yes.
So here this is called ER model. Here,
Mm-hmm.
as I described, this is this scenario. I'm describing it in star schema.
Okay.
So as we saw this, you see all the attributes are there. As I said, you can take it as a master data for everything like material and salesperson and sales department. When you have a strong entity, it is a dimension in our star
Mm-hmm.
schema. It is a dimension and all the attributes we have as attributes for the in the dimension we
Okay.
have as a characteristics in the dimension. So how we model is we make a strong entity that means which forms the group like customer. You can name a customer dimension and you can group a few characteristics into the dimension. You can create one dimension called customer and you can you can add customer ID, name, city, phone number. Like that material, you can create a dimension. You can add color, price, material ID, name, and type, etc. So just like that, you can design different dimensions, right?
Yeah.
So that is, you're following me, right?
Yeah, yes.
Here you can see for the star schema, we have the same dimensions. That is why I took one example and shown you in different models. So
Okay.
here we have a material dimension, we have salesperson dimension, time dimension, and customer dimension. So we have all the same characteristics grouped together into the dimension.
Mm-hmm.
So we have a fact table. So each and every dimension has a dimension ID.
Yes.
That dimension ID is stored in fact table, with the help of surrogate keys. So the relational link between dimensional table and the fact table is a 4 byte surrogate key. So there is a 4 byte surrogate key, which is numeric key. So that will be stored in fact table, and there is the ID of the dimension table. Just like that, you have for the salesperson, there is the ID 4 byte. So that one
Yeah.
is stored here, and you have a time dimension ID, and that is I mean it will be generated by the system,
Mm-hmm.
and that will be stored in the fact table. So that's how it will be relationally linked to the fact table. And in dimension tables, what you will find the IDs of the all the dimensions. I mean, in technical terms, surrogate keys and
Mm-hmm.
the key figures.
Okay.
You have surrogate keys and the key figures in fact table. And in
Okay.
dimension tables, what you will find characteristics in dimension table. And
Okay.
characteristics are grouped together according to the dimension.
Okay.
So I mean, for example, here as you can see the multi-dimensional model.
Mm-hmm.
So it is a simple but effective concept which is easily recognized by technical resources as well as the business analyst. So anyone can recognize it. I mean, because it is simple concept and it is effective at the same time. So here, in fact, what is star schema? Star schema is, it graphically represents star. I mean, dimension fact table in the middle and the dimension surrounded, because this is the basis for our, BW concept. You
Yeah.
know, because here these are the basics, as I say, star schema and snowflake schema, because this is what BW is built on. We are not going to come back, but it is important to understand these two concepts. These two are simple, but all the info cubes and DSOs, all the data, data targets are designed according to the schemas. So here star schema is represents a star, and we have a fact table in the middle and the dimensions surrounded. So that is why it represents graphically a star. That is why it's called star schema. And then we have dimension IDs, which are 4 byte keys, surrogate keys, and which are generated by the system. And each dimension has the key, and those keys are stored in fact table. And then in fact table, what you will find dimension IDs and you will find key figures. And in dimensions, you will find the characteristics.
Mm-hmm.
So there is the difference. In
Okay.
Snowflake schema is the enhancement of star schema.
Mm-hmm.
So you have a star schema. You understood the star schema. No, Snowflake schema is just the enhancement of star schema. Snowflake
Mm-hmm.
schema also represents the star, the fact table in the middle, and surrounded dimensions surrounded by the fact table,
Mm-hmm.
and you have surrogate keys of every dimension which are stored in fact table, and you have key figures along with surrogate keys. So here also fact table consists of the dimension IDs and the key figures. Here also dimensions consist of the characteristics which are describing the dimension. So you group the characteristics and you create a dimension like material and salesperson and customer, and you keep some characteristics in that relevant characteristics. So there is a concept. So what will happen in what is the difference between star schema and snowflake schema? In star schema supports historicity, whereas snowflake schema supports both current display and historicity.
Okay.
So star schema, you will see historical display of the attributes, but in Snowflake schema, you will be able to see the current display of the attributes as well as the historical display of the attributes. So how is it possible? It is possible because the here in Snowflake schema, dimension IDs are connected to the fact table. Fact table is connected to the dimension IDs through dim IDs, and dimension IDs are connected to the master data table through SIDs. there is a concept called SID, which is added to the star schema. So for
Mhm.
by adding that one, what is made possible? The current display of the attributes is made possible. For
Mhm.
example, you have a characteristic customer ID, and it can be now it can be used in 100 or 150 info providers at the same time. How it is possible means the value doesn't be, you won't be able to see the value of the characteristic, but the key of SIDs, it accessed by the SIDs. I mean, you will have the SID for that. There is also a 4 byte key. So
Mhm.
here, yeah, system will generate a simple 4 byte key uh, to the dimension IDs, which are called surrogate IDs, dim IDs, and all those dim IDs are stored in the fact table. So with the help of dim IDs, the
Mhm.
fact table is relationally connected to the dimension IDs, dimension
Mhm.
table. So with the help of with the help of fact table, I mean dimension ID, fact
Mhm.
table is connected to the dimension ID, dimension table of customer. That is called
Mhm.
historical display. Here you can see historical display of the phone number. But
Mhm.
I mean there is a feature added with the help of SIDs. Dimension table is connected to the master data table. That is called current display.
Okay.
So this is the concept and this is the enhancement. You have both the historicity and the current display of the attributes. And
Mhm.
I mean the same phone number. You can see the same phone number is a historical attribute in the dimension. And if you view it in the master data table, it is a current attribute. Because we load master data before transaction data, I mean we load the customer and its attributes before data in the system first, and then the transaction data takes place, delta takes place, data keeps adding up, and in reporting you can see, I mean you will have, for example, if you have a customer ID in reporting,
Mhm.
in a query you added a customer ID, you haven't added a telephone number. But
Mhm.
in report, you can, by using the master data, you can view telephone number. That is called current attribute. So that is called current display.
Mhm. Okay.
So this is the overview of data models. And for example, you have a transactional data model and a flat structure, and star schema, snowflake schema. So performance-wise, transactional data model is poor. Flat structure is okay. It is good. The star schema is very good, and the snowflake schema is very good. So here, complexity is medium for the star schema, and snowflake schema it is very high. And historicity, transactional data models won't have historicity, it is old.
Mhm.
And flash structures have historicity. And star schema have a historicity as well as snowflake schema. So it is all these three data models can be used in OLAP systems. So
Okay.
here, current display, transactional systems can do current display, and the flat structure can't display. And star schema, there is no current display, and snowflake schema, there is current display is available.
Okay.
So here you can read the document, and you have I
Mm.
mean the document with you, so
Yeah.
you can. And now we can go to the another document which I have. I will be sending after the class. So here,
Okay.
this is about the data flows, SAP BI data flows. In this, we have SAP methodology, source system, CTTL, extraction, transforming, and loading data, and BW architecture, differences between BW 3.5 version and 7.0 version, and data flows by graphical representation, and data flow in 7.0, and the steps to create data flow, etc. And you will have some conclusion. So ASAP methodology, we will first discuss it because this is the project life cycle, and we are going to discuss it. So here, first of all, I want to introduce to the BW system. I'm going to get a remote access today. I have to go there.
Okay.
So here you have a logon pad, SAP logon. Here you will see BI 7.0 ECC server. So SRM we
Mhm.
don't need it. We have ECC and BI 7.0. These are the two servers we use. So
Mhm.
here ECC, as you know, the database. It is the database,
Mhm.
and here we have a there is OLTP system, and we have a OLAP system which we work on. So here you have it is the part of NetWeaver 2004S,
Mhm.
and you can see that there. So we will see it tomorrow. No problem.
Okay. Okay.
First, there's a problem in this.
Okay.
So I mean, you will be accessing the remote server. You can access it from anywhere or
Mhm.
anytime.
Okay.
I mean, I'll get the user ID for you.
Sure.
Here, in accelerated SAP methodology, is something which describes the life cycle of the BW project. So when
Mhm.
you have a BW project, there are different phases in a BW project, like project preparation, business blueprint, realization, final preparation, and go live and support. These are the phases of the BW project. So in the project preparation, what you will do is, I mean, there is not something which we do, but it is done in high level. So understanding the legacy system landscape and architecture, like system site and volume of data, system landscape, slicing, etc. All that project managers do, and resource extractions, like how many resources we want, and project plans and budgeting, training required to resources, etc. All these things are, all these um requirements are taken care in project preparation phase. After that, there is another phase called business blueprint. Here, understanding of the requirement, what are the modules we have to do, and collecting all the legacy reports. For example, we have different old reports. All
Mhm.
the old reports we have to collect that. In ECC,
Mhm.
we will collect the reports, and sometimes we need to create the similar reports in BW. So, and we need to enhance those reports and create new reports. So
Mhm.
legacy source systems and legacy reports, we understand them and we collect them, and understanding the functional specifications, and design and develop the data models or data flow diagrams, and designing the technical specs. So all these will be in the business blueprint phase. So here, functional. If you have a lot of experience in BW, you will be involved in business blueprint itself. And generally, a typical BW consultant, BWBI consultant will be involved in realization phase. So
Mhm.
this is where we take the functional specifications and we create our own technical specifications. Functional specifications is a document which has the business requirements, and from that we create, by taking that business requirements, by taking that specification, we can create a technical requirement. So what kind of DS data source we want, and what kind of DSO we want. For example, I will show you here. Here you have this scenario. So for this scenario, for the production plant,
Mhm.
we had to create a report. So you will see the technical specs here. This is a functional specification.
Mhm.
Generally, you have in an organization, you will have a lot of agreements and signing, etc. So
Mhm.
everyone has to, for example, represent. There are a lot of representatives from the client side and from the company side who have to agree with
Mhm.
the specifications and all that. After that, you will have a business requirement like this of the report.
Mhm.
By taking this, requirement of each and every query separately. For example, for this report, you have another requirement for this report, and
Mhm.
you have buckets. What are the buckets we want, etc. I mean, what actually we want? Like we have a transaction, we have transaction codes Q11, Q11, MICO. So what is the formulas we want? I mean, how do we calculate the days, etc. All that will be given. And for that, you have a report. I mean, technical specs. In technical specs, you will have all the BW requirements, like which DSO we are going to create. What are the, what do we want from the DSO? Like, are we going to use override or are we going to use summation? Everything will be described in the technical specs. We have to create technical specs. We have to take functional specs and we have to create technical specs and we have to do the data modeling. So there will be like different people will take different tasks. So
Mhm.
like someone will create documents and someone will create data modeling, etc.
Okay.
So here you have, in realization phase, all those will take place in realization phase. Here, installing and activating the standard business content. For example, you have a new system and you have to install all the transactions which are going on in ECC and in the standard business content you will install as is process. I mean, just as they are, few of them you have to install them. After that, every business has its own requirement. So you might have to create new data sources, or you might have to enhance the already existing data sources, and you might have to create DSOs, cubes as a part of 2D process. How do you create 2D process? For example, a company is there, and you have implemented a company has implemented it for SAP and BI for US, and they want to. I mean, they don't. They have a lot of data for US itself, and they want separate DSOs and they want separate cubes for the EU. So what will happen then? You have to create you have to create a copy cubes and name them for EU, and then you will create a copy cubes for Asia Pacific. Like that, you can create copy cubes and load the data from the same data sources by having the filter for US and EU and Asia Pacific data. So you can have a different data in different cubes and report for the performance region. So that's how you can do. I mean, because they will have, I mean, there will be different managers and different reporting, managers. So there is one requirement. So designing and developing the data flows, process chains, unit testing, integration testing, and transportation are done in this phase itself. So all of them are done in this phase. So in final preparation, what you will do is, in realization phase, you will develop. the data flows, and in realization phase itself, you will transport it to the quality system, and you will do the testing in quality system, and then you will transport it to the production system. So that is called final preparation in production system. That phase is called final preparation. So in final preparation, you will validate the objects in the production system and applying the settings to the production system, like a pre-go live checklist. You have SPRO transaction. In that, you have to do some settings for the currencies and units, etc., etc.
Mhm.
So all the settings you will do, and pre-go live checklist, and then you will do prepare for the end user training, and that is all the things will fall under final preparation. And after go live is like, you have you have done all the init loads, and then you keep them in the delta process, and you execute them, and that is the go live, and then you have to monitor the data loadings, and support guys will come into picture. Here, the support phase is the support, go live and support. So, can we discuss source systems tomorrow?
Yeah, yeah, sure.
So, we will discuss source systems and ETTL process and
Okay.
differences tomorrow, and data flows.
Okay.
Okay, Ravi, then see you tomorrow. Say, what time we'll meet tomorrow?
Uh, so today we started at 7:30, right?
7 o'clock. No? Uh,
Oh,
yeah,
yeah,
7:30
it's
your
7.
time.
Okay. You want to take the same time?
Yeah, that's not a problem. Yeah.
Okay.
Is it good for you?
Yeah, it's good for me.
Okay. So I will meet you 7:30 Central tomorrow.
Yeah, sure.
Okay.
Okay.
Okay. Bye.